Greetings, mathematicians of all ages. Our last lesson in this chapter is patterns of changing metric units. Now, hopefully you remember all the metric units we discussed earlier this year. For capacity, that's going to be milliliters, liters, and kiloliters. For mass, it's milligrams, grams, and kilograms. And finally, for length, we have millimeters. This one had that one extra one, centimeters, meters, and kilometers. Why don't you pause the video and see if you can remember each of the actions for each of those? Go ahead. So hopefully the actions are still in your brain, so you kind of remember how big each is in measurement. Today we're going to do a lesson where we want to convert between units of measurement within each type. So in capacity, I may want to change from liters to milliliters, or in measurement, in length, I might want to change from kilometers to meters. Okay, so we're going to convert today. The reason for that is later in math and science classes, you're going to need to have that ability. Okay, before we start that, I'm going to do a slight mini lesson on mental math rules, and that is when we're dividing or multiplying by a factor of 10. So we've already done exponents now, and so we know what each of these would mean. And I could have you pause and figure each of these out, but it's not, it's probably not worth our time. So 10 to the first is 10, 100, and so on. And all you notice is that each time your exponent increases by 1, your number of zeros increases as well. Okay. Today in our lesson, we're going to be multiplying or dividing pretty much always by 1,000 and 100. But to do that, there's a very fast mental math way to do that. So I want to show you. Okay. So let's just start with a number, something like 56.23. Okay. Now, anytime we multiply by a factor of 10, so any of those exponent, 10s that I showed you, 10, 100, 1,000, etc. If I multiply by any of those, the fast way to do that is however many zeros there are, the decimal shifts that many places, okay? And when I'm multiplying, it shifts to the right. So this would become 5,623. If I did 56.23 times 1,000, once again I'm doing multiplication, so it's going to shift to the right, and I'm going to shift it 3 places. So just to jump back there, I went whoop, whoop, shifted it twice, okay? And that's how I ended up with 5,623. But if I'm multiplying by 1,000, let me just rewrite it down here so you can see. I'm going to shift it 3 times because I have 3 zeros, and it's again to the right because I'm multiplying. So 1, 2, 3. And our sound effect for shifting decimals, I don't know if we've done it this year yet, is whoop. Okay, so I'll just do that with the sound effect. Whoop, whoop, whoop. Now, if I ever am shifting and I end up with a blank spot like this, some of you probably already guessed I have to add a 0 there. Okay, so this one would turn out to be 56,230 because I shifted it 3 places and I ended up with that. Let's just try one more with multiplication. So let's say I have 0.2754, doesn't really matter, times 10. Okay, I'm multiplying, so it's going to go to the right. I have 10, so it's only going to shift once because of the 1 0, which means it would go whoop, and my final answer would be 2.754. Okay, and let's just do one more multiplication for good measure. If I'm going times 10,000, you can see there's 4 zeros, so it's going to shift 4 times, whoop, 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 right? And I end up getting 2,754. Now, the only difference in division is that when I divide, I'll even use the same number here, when I divide, I still look at the number of zeros, but the thing that changes is the decimal shifts to the left for the number of zeros, okay? So I have the decimal here. Since I'm dividing by 100, I'm going to shift it 2 times to the left. Whoop, whoop. So this would end up being 0.5623, okay? Now if I start with a whole number like 27 divided by 1,000, if it's a whole number, the decimal for any whole number is right after the last number, okay? So now I got to shift it 3 times to the left because I'm dividing. Whoop, whoop, whoop. Once again, if I have that little spot there, I have to fill that in with a 0, and I get 0.027 Okay, this process and the one that we just used with multiplication will be extremely helpful today when we're converting between metric units of measurement. All right, so let's get right into it. What I want to do is give you this helpful table, and for now in 6th grade it's going to be helpful. It may not make a ton of sense, but it'll hopefully make more sense as you get older and you have to do more of these and see why this works. So I'll bring up the table. All right, so here's the metric conversion table. I need you to pause, copy this all down, and I'll explain it after you finished copying it. Go ahead. All right, so here's how this table works. This is our metric conversion table, and again, this is pretty much only going to work now in 6th grade, but it'll start to get you used to some of these concepts. Okay. All right. The first thing, the first column you can see says which way, and what we're always going to ask is, when I'm converting, am I going from a bigger measurement to a smaller measurement, or from a smaller measurement to a bigger measurement? And I'll write it on this page. Do this below your table. Obviously, don't do it as part of your table, but I want to have this up while I'm talking. So something like this. If I have 5.4 kilometers and I want to know how many meters that is, what I'm doing is going from kilometers to meters, okay? And if you do the actions, you know that kilometers is bigger than meters. So what I'm doing is going from bigger to smaller. So that would be this part of the table, okay? Bigger to smaller. What am I supposed to do? I'm supposed to multiply by 1,000, and I'll get to this chunk in a second here. I guess I will go to a new page. All right, so I did 5.4 kilometers to how many meters, okay? Now, we know it's going bigger to smaller, so I start with the number, whatever number was here. I always start with that. And then we said we're going to multiply by 1,000. Now, using that mental math rule I just showed you, since we're multiplying, it's going to go to the right. And since there are 3 zeros, it's going to go 3 places to the right. Whoop, whoop, whoop. You're going to see that ends up being 5,400 meters. Let's do another bigger to smaller and not use meters here. Let's do 0.24 liters equals how many milliliters? Okay, looking at the table, liters and milliliters, we know this one's bigger, so I'm going bigger to smaller, which says I gotta multiply by 1,000, so I'm gonna do 0.24 times 1,000. That equals 240, which I'd put in the blank. All right, now let's get to a couple smaller to biggers. Okay, so that'd be something like I don't know, 34,250 milligrams is how many grams? Okay, looking at the table, I already told you it's going to be a smaller to bigger. And in that case, the table says I'm going to divide by 1,000. Since I'm dividing, now I'm going to go to the left 3 times. Remember, if there's no decimal there, I'm going to put it right after the last number. Whoop, whoop, whoop. Whoop, a little far on my last whoop there. So we're going to get 34.250 for that one. Okay. Now let's get to the exception. You'll notice on the far right side of your table it says, unless the problem involves centimeters, then we're going to use 100. Okay. So a good example of that is something like 3,542 centimeters equals how many meters? As always, on any of these, I'm going to first check bigger to smaller, smaller to bigger. So I think about centimeters to meters. That's going to be smaller to bigger, right? So I put the number. And in this case, I'm going to divide. But since the problem involves centimeters, I'm going to divide by 100 this time. The decimal would be here, and I'd only shift it 2 places because of the 2 zeros. Right? And I get 35.42. So that's the main difference. With centimeters this year, it's not always going to work. For centimeters this year, I'm going to use 100. Okay, so let me just jump back to the table here. So if you use the table, you should be fine on this lesson. Thinking about bigger to smaller, smaller to bigger, always using 1,000 unless centimeters is involved. The last tricky part, I'm not going to make you do too much of this, is where it kind of jumps 2 steps almost. For example, if it would go from milligrams all the way to kilograms, we kind of skipped grams in the middle. What you'd actually have to do is do the process twice. But again, I won't make you do many, if any, of those. So again, this lesson will be useful later, as you need to convert between metric units, probably in math and science. All right, see you next time.